Welcome back, smart mathematicians. Let's do question 10b2. The following information is given: f prime x is equal to x plus 1 squared minus 4, and then f of x is equal to 0 is 1 negative real solution. Using the information above, sketch f of x on the set of x's alongside. Label the x values of the turning points and x value of the point of inflection. In question 10b1, we managed to sketch the graph of the derivative function. Right, we have to remember that the derivative of a cubic function is parabolic or is quadratic. And then the derivative of the quadratic function is linear. We have to remember that the x-coordinates of the turning points of the cubic graph become the x-coordinates of the x-intercepts. And the x-coordinate of the point of inflection is or becomes the x-coordinate of the turning point of the derivative graph. We have to know that. Let me write it down. We are moving from the derivative graph to the cubic graph. So let me write like this and say x-coordinates of x-intercepts of the derivative graph, in this case, which is quadratic. The derivative graph is quadratic. The x-coordinates of the x-intercepts of the derivative graph are the x-coordinates of the turning points. Let me write the TP for turning points of the original graph, which is the cubic graph of the cubic graph. Okay, remember that. The x-coordinates of the x-intercepts of the derivative graph, which is quadratic in this case, are the x-coordinates of the turning points of the cubic graph. And then the x-coordinate of the turning point of the derivative graph, in this case, which is quadratic. Remember I said if you derive the cubic function, you get a quadratic function. If you derive a quadratic function, you get a linear function. So the x-coordinate of the turning point of the derivative graph, in this case quadratic, is the x-coordinate of the point of inflection of the cubic graph. This is point of inflection of the cubic graph. Remember those. So now we have our x coordinates of the x-intercepts, which is x equal to -3, or x is equal to 1, and then the turning point. So in these three lines, here we have the turning point, here we have the point of inflection, here we have a turning point. It says f of x has one negative real solution. So we must have an idea about the shape of our graph. So if you check here, the coefficient of x squared is positive, meaning that even for our cubic function, f of x is equal to ax cubed plus bx squared plus cx plus d. It means a also for our cubic function is positive. So if a is positive, remember the graph is shaped like this. If a is positive, the graph is shaped like this. And then if a is negative, the graph is shaped like this. If a is negative, the graph is shaped like this. I just use these two. If it's positive, the last arrow is pointing upwards. If it's negative, the last arrow is pointing downwards. This is how our cubic function graph is going to be shaped. It has one negative root. This is the turning point. We have x coordinate of the turning point, which is the same as the x coordinate of the x-intercept. And then we have the x-coordinate of the turning point there, which is also the same as the x-coordinate of the x-intercept there. And then point of inflation, the x-coordinate of the point of inflation is the same as the x-coordinate of the turning point of the derivative graph. There's one negative root, so it means it should be somewhere there. So it means we can have that root there, and then can easily sketch our graph like that. You see that? So it is cutting the x-axis at one point. Then we have sketched our graph. It is one negative root, so which is this one, and then we have our graph shape like that.